Today I have discussed Phasor method. Phasor method. Okay, basically this method is more suitable for series parallel combination circuit. Okay, in case of AC circuit, is more suitable for series parallel combination circuit. Okay, so first of all, suppose that a resistance R1, inductor L1 or capacitor C1. Second one, resistance R1, R2. Okay, this one, this is inductor L2, capacitor C2. Okay, and third one, R3, L3 and C3. Okay, this combination of three, R1, L1, C1, R2, L2 and C2, R3, L3 and C3. This one is connected to a supply voltage V and frequency F, and current going through source, that is capital I. Okay. Now, first of all, we have considered current I1 in this I1 and I2 and I3. Okay. Our motto, determine capital I with the help of phasor. Okay, with the help of phasor. So first of all, I know that Z1, Z2, Z3, combination of R1, L1, C1 is the Z1, the combination of. What about Z1? Z1 is written as R1 plus J XL minus J XC. Okay, it means R1 plus J XL, which one is greater? Or you can say that like this one, that is Z1. Similarly, Z2 is written as R2 plus J XL minus. Okay, and similarly Z3 is also written as R3 plus J L1 that is, and that is X. Okay, like this one. This is the Z1, Z2 and Z3. What about mod Z? Mod Z1 is written as R1 square plus XL1 minus R, like this one, and mod value of I2 Z2 is written as R2 square plus XL2 whole square, and mod of Z3 is written as R3 square plus okay, Z1, Z2, Z3. Now, what about I1? If you want I1 is supply voltage, that is V. So V divided by Z1. Okay, V divided by Z1. But what about mod value of I1? If you want mod value, means mod V divided by mod Z1. Okay. What about phasor angle of I1? Phi1, this will equal to tan inverse of XL1 minus, or XL1 minus XC divided by R1. Okay. Suppose that this value is negative. Suppose that if XL, suppose that phi 1 is negative. Let us consider, let phi 1 is negative. If phi 1 is negative, then what about I1? In phasor you can written as mod I1 at the angle minus phi 1. If you want to make phasor diagram corresponding to this circuit, this I1 like that is I1 corresponding to, if you want to make, that is I1 this is equal to mod value and this is the angle. Okay, so complete representation of I1 in phasor diagram. After that, what about I2? If you want to make I2, then how can make it? I know that how can draw the I1, that is XL and this is R1 and this is mod Z1 and that is phi 1. So tan phi 1 this is equal to XL1 minus XC1 divided by R1. Okay, that's why. Clear? Now another way, we are focused on Z2. Now what about I2? Suppose that I2 is, if you want to I2 means V divided by this impedance, V divided by Z2, and in magnitude wise mod V divided by Z2. Z2 is, you can say that Z2 mod. And what about phi 2? Phi 2 is, tan phi 2 is written as XL2 minus XC3 XC2 divided by R2. Let again, if phi 2 is positive, then what about I2? I2 is written as mod I2 at the angle plus phi 2. If you want to make I2 in phasor, this is I2, suppose that this is I2. Okay, clear? And what about angle? That is phi 2. Now next target, what about I3? What about I3? I3 is written as V divided by Z3. Okay, so in magnitude wise I3 is written as like this one. What about tan phi 3? Tan phi 3 is XL3 divided by R3. Let suppose phi 3 is positive, then what about I3? I3 is written as mod I3 at the angle plus phi 3. Okay, so if you make I3 like that is I3. What about angle? That is phi 3. Okay, our motto, determine all combination resultant of this one. Okay, the combination of I1, I2 and I3. Suppose that whole resultant is make like this one. Okay, the combination of all three like this one, that is capital I. And what about angle? That is phi. The resultant of these three, I1, I2 and I3, final resultant of I1, I2, I3 is I. Okay, if you want to make here, here and here. Okay, clear? Now how can resolve? This is the phasor diagram. This is the phasor diagram. Okay. Now how can you resolve? I component in x direction, that is I cos phi, and I component in y direction, that is I sin phi. Okay. Now another way, I1 component I1 is also resolved in x component and y component. Suppose that this is I1 cos phi, y I suppose only I and angle phi, that's why I cos phi, and y direction I sin phi, in y direction that is I sin phi, I1 sin phi, make like this one. Similarly I2, that is I2 sin phi, and here I2 sin phi, I2 cos phi, I2 cos phi. What about I3? I3 also written as I3 sin phi, and here that is I3 cos phi, I3 cos phi 3. Clear? Now first of all, what about resultant along x-axis? Our motto, determine first of all resultant. You can see the component of resultant current I along x-axis. The component of resultant I along x-axis. So I cos phi is written as I1 cos phi 1 plus I2 cos phi 2 plus I3 cos phi 3. Okay. I1, I2, I3, I1 cos phi 1 plus I2 cos phi 2 plus I3 cos phi 3. Okay. Now as y-axis. So in case of y-axis cos phi, it is written as I sin phi 1. Okay. If you want to corresponding to negative, if you want to some I1 sin phi 1 like this one, you can also make it here. Okay. If you represent here, then written here like this one. In this case it is written negative. Okay. In this case, because of this is an opposite direction, otherwise if you written here then I sin phi 1, then it is negative. Okay, because of opposite direction, that's why. Or if you represent like this one, then here written corresponding to this one. Otherwise you can also represent here and with negative sign. Okay, or this one or this one, plus I2 sin phi 2 plus I3 sin phi 3. Okay. Now, so what about resultant current? The combination, this is the first and this is second. Okay, is squaring both side and adding. If we squaring both side, then we got sin square phi plus cos square phi, and I is common. This is equal to the combination of this one, I1 cos phi 1 plus I2 cos phi 2 plus I3 cos phi 3 to the whole square plus I1 sin phi 1 plus I2 sin phi 2 plus I3 sin phi 3 to the whole square. So what about I? I is written as under root of combination of this one, that is suppose that capital X and that is capital IY. So capital IX to the whole square plus capital IY to the whole square. What about capital IX? IX is I1 cos phi 1 plus I2 cos phi 2 plus I3 cos phi 3, and IY is written as I1 sin phi 1 plus I2 sin phi 2 plus I3 sin phi 3. Okay. Now what about 1 by 2, sorry 2 by 1? We got tan phi. Tan phi is written as minus I, or you can say direct, that is Ix divided by Iy. Okay, clear or not? If phi is maybe positive, phi is positive, then in that case current is leading. Okay, current is leading. Otherwise, if current is phi is negative, then current is lagging. Okay, lag behind the applied voltage. You can write now, if I is positive, first of all make it, if phi is positive, current I means resultant, I will be lead the applied voltage because of V has taken reference, V at the angle 0, that is reference. Okay. If you want to make V, then V at the angle 0 here represent like. Okay. Now if phi is negative, the current I will be lag the applied voltages. Okay, so first of all make it, after that we have focus on numericals. Now our motto, find the total current draw by circuit and its power factor. Okay, circuit is given like this one. So first of all our motto, determine I1 I2, after that I. Okay, the combination of I1 I2. So how can determine I1 in branch 1? What about Z1? Z1 is written as 50 plus J42. Okay, I1 Z1 like this one. So what about magnitude? Magnitude is under root of 15 square plus 42 ka whole square. So what about this value? We have already solved 44.6. That is, we got 44.6. I have already solved. Okay. Now, so what about I1? I1, if you determine I1, mod value of I1 is V divided by mod Z1. So V is 200 divided by 4.44.6. So we got finally 4.48 ampere. So now what about angle phi 1? Phi 1 is tan inverse of XL1 divided by R1. So tan inverse XL1 is 42 divided by 15. This one is 70 point something, 70 point, I have already solved 70.35. Inductor, that's why it is lagging. Clear or not? That is lagging. Okay, if you want to make, so what about I1? Finally I1 is mod I1 at the angle minus phi 1 because of lagging. That's why I represent minus. Okay, so mod value of I1 is 4.48 at the angle minus 70.35 degree. So first of all, if you want to make, that is V at the angle 0, we have consider V at the angle 0, that is reference. Then what about I1 corresponding to here, that is minus 70.35. okay, and that is I1. If you make 4.48 ampere, So I1 represent like this one. Now next target is what about I2? So in case of branch 2, what about Z2? Z2 is minus J 47.6 ohm. So what about I2? I2 is V divided by Z2. V is 200 divided by Z2. Z2 is 47.6. 47.6. What about 40? That is 1.5. Sorry, 4.2. This value is 4.2. 4.2. Clear? That is 4.2 ampere. Okay. Now what about phi 2? Phi 2 is written as tan inverse. What about R2? R2 is not given. That's why we can say XC2 divided by R2. R2 is 0. Okay. If you want to make tan inverse whatever 47.6 divided by 0, that is infinitive. So tan inverse infinitive is 90 degree. So phi 2 is 90 degree. And capacitor, in capacitor, that's why it's capacitive. So you can say that leading. Okay, power factor leading. So what about I2? I2 is written as 4.2 at the angle plus 90 degree. So if you want to make I2, then I2 is I2 like this one. I2 in magnitude wise 4.2, and what about angle 90 degree. Now after that we have draw the phasor diagram of resultant. Okay, so first of all determine I, then we draw the phasor diagram, final phasor diagram of I. Okay, so first of all the component of I1 in x direction and in y direction. Similarly draw phasor diagram corresponding to I2 in y direction, that is 4.2 sin 90, and here 4.2 cos 90. Similarly draw phasor diagram corresponding to 4.48 cos 70.37 minus, and here 4.48 sin of minus 70.35. Okay, clear? So first of all make it. So resultant along I. Now our motto I. So Ix, or you can say resultant component along I resultant component along x axis is I cos phi. I cos phi is written as corresponding to 4.2 cos 90 plus 4.48 cos 70 minus 70.35. Okay, clear or not? So we got this value, we got 4.5, we got, that is 4.25, sorry 1.5 ampere. Now similarly I sin phi is written as 4.2 sin 90 and plus along corresponding to this 4.48 with angle minus 70.35 degree. So we got that is 0. Okay, we got Ix in case of y direction, resultant current along y direction is 0. Okay, so first of all I know that is Ix and that is Iy. Okay, so I square, this be equal to Ix square plus Iy square. Okay, now so what about I? Ix is 1.5 ampere to the whole square, Iy is 0 to the whole square. We got 1.5 ampere. The final answer is in magnitude wise 1.5 ampere. And what about angle? Phi is equal to tan inverse Iy divided by Ix. So tan y, this is tan y is 0 divided by, that is 1.5, that is tan 0. So phi is 0 degree. Okay, if you want to make I this equal to 1.5 at the angle 0 degree. So if you want to make here, then 1.5 ampere resultant of these two, that is this one and this one is I is 1.5 at the angle 0. So what about magnitude? Magnitude is current magnitude 1.5. And what about power factor? Power factor means written here, power factor of the circuit. Power factor of the circuit is cos phi cos 0. So cos 0 is 1, that is 1. Okay, and phasor diagram corresponding to this one. This is the phasor diagram of the circuit. This is the phasor diagram. Phasor diagram of the circuit. Okay, given circuit. Make it.